Hi, I'm Larry Puckett, the DCC guy. Today I want to talk about frogs, and I don't mean the kind that croak out in my backyard every spring. Instead, what I'm looking at are the frogs in turnouts. You know, on some of these they're powered and some of them they're not. And it can be critical with DCC when you don't have powered frogs. So let's go ahead and get started. Okay, so as I said, there are a number of different types of turnouts that are very popular in the United States that have dead frogs. Basically, you know, we have microengineering, and this frog right here, it's a bronze, cast bronze insert, and it's not electrically powered. You have to add a pickup to that, a feeder, in order to power it. And you have to provide a way to keep the polarity correct. This is a Walther's turnout. It has also a dead frog, and you can see I've already added a wire to that so that I'll be able to electrically power this frog and keep the polarity correct. Atlas turnouts, for example, they are also the type that have an electrically dead frog. And the problems that you run into with this with DCC is that basically a DCC decoder is a little computer. And you know what happens, you know, during an electrical storm or any other thing when power to your desktop computer is interrupted. You know, it cuts off, it shuts down, and it has to restart and reboot and everything else. Well, the same thing happens with your decoders. If they go over a dead frog, chances are they might stumble. And if they lose power, then it has to reboot and start up all over again once it gets power back to its wheels. Now, there are ways to fix this. On the Piedmont Southern, most of my turnouts, I have the frogs powered using the switch on the tortoise switch machines. And that allows me to have correct power every time that I throw the switch. There are a number of other ways to do that. And what I want to do today is show you one very nice, very reliable method to power your frogs if you don't use turnout switch motors like the tortoise or any others that have some kind of built-in switching mechanism to control the polarity of your frogs. So let me zoom in here on the workbench and we'll take a look at what I have to show you. Okay, so what I want to go over today are a couple of several devices here that I have here on the benchtop that you can use to control the polarity of the frog on your turnouts, while at the same time providing a constant source of power to that frog using feeders like I just showed you on that Walther's turnout. Now these devices, all three of these, are made by the same company, Tam Valley Depot, and they are called frog juicers. And what they do is they take power supplied by your DCC power bus, and there are two wire contacts here on this screw terminal, B and A, that are identified on the outside, and those receive power from the DCC power bus. And then there's one terminal here in the middle that's identified with an F that goes to your frog. So basically these are a solid state switch that trips at a very fast speed, something under 150 microseconds. When it detects a short, when your locomotive wheels cross the gap between the tracks and the frog, if there is a mismatch in polarity there at the frog, this will detect it, and it will switch it in under 200, somewhere between 150 and 200 microseconds. Now that 150 and 200 microseconds, that's measured on the bench top with sophisticated electronic equipment. On your layout, it may be a little bit faster, somewhere closer to 200 microseconds, but it's still a lot faster than what you'll see on other devices such as command stations. For example, the Digitrex command stations, their default is, I believe, an eighth of a second, and using up switch setting 18, you can extend that out to a half a second. Now that's 500 milliseconds. So these suckers are going to fix the daggone short circuit before your command station even sees it. Okay? Now, this is called a mono frog juicer because it has only one frog output and it will only power one frog. Now, This, though, is called a dual frog juicer, and I guess you can probably figure out why. These are the two inputs for your DCC track power bus, wires coming into it, and here we have a pair of terminals for the frog output. Okay, it's labeled frog so that you won't get it mixed up. And there's a couple of LEDs that come on when it's powered. So it works very well, works the same way as the mono. It's just two mono circuits on a single board. Okay, it works at the same speed, that 150 to 200 microseconds. Now, one of the neat things about this one, though, is it has this little jumper right here that you can use to reset the device so that both of these outputs at the frog are powered. Okay, they're paired so that they will go to two rails in a reversing loop and handle the polarity change for both of those rails. So you can use this as an auto reverser with reverse loops on your layout. And it's a very simple, all you have to do is change that one jumper and you've got an auto reverser instead of two dual frog controls. So the power comes in here and you have two outputs here for controlling polarity and power to two separate frogs, or for controlling the polarity and power of two rails in a reversing loop. Nice little device and works very, very quickly. Now, for economic standpoint, you can't beat the hex frog juicer. And again, hex, there are 6 frog outputs here. So again, you've got 2 screw terminals here. No soldering to these boards. Everything is handled using these little screw terminals. Okay, so you got DCC power in and 6 outputs to 6 separate frogs. So that gets your cost down even further. So you got a choice. You can go with mono frog juicer, dual frog juicer, or hex frog juicer to control 6. Now, I use these, on my layout, I mainly use the switching contacts that are provided on tortoise switch machines in order to control the polarity of my frogs. However, there are a few cases where that doesn't work out. So I used these monofrog juicers to control the polarity of the frogs on my gantlet track that I wrote about. I believe it was in October 2014 issue, and I'll put a note above so that you can see exactly where that was. And these do a great job of handling that the polarity on the gantlet track. I also used these. I used a dual on a Walthers double crossover because, there are 4 turnouts on that double crossover, and you need to be able to control 4 frogs. And fortunately, I was able to pair 2 of them together so that I could get away with using a single dual frog juicer to do that. Works great. I also use this on my turntable to control the polarity of the rails on the turntable itself so that when the turntable reverses, it doesn't shut down power due to the phase change. Other than that, these things work great. Now, I did run into one problem. When I was setting up the double crossover, I ran into a really, really sticky issue that it took us about a month to figure out what was going on. And that was about half the time when a locomotive went through that double crossover on the Walthers double crossover unit, it would trip a circuit. And half the time it wouldn't. And that was driving me crazy because I couldn't figure out why did it only work about half the time and not the other half. Well, finally, after a lot of discussions with the developer of the frog juicer and the developer of the PSX circuit breakers, which I use on my layout, we were able to figure out what was going on. As it turned out, the default trip speed on these, or trip time, is 150 to 200 microseconds, and that's about the same thing as the default trip speed on the PSX circuit breaker. So it was a throw of the coin as to which one tripped first. Sometimes this one would trip first, sometimes the PSX would trip first. What I was able to do, though, since this one can't be changed, I was able to change the trip speed of the PSX board. And that's something that's been around on various versions of the board for a long time, although there was a problem with the version F boards that sometimes it wouldn't work. But you can go ahead and you can extend the trip time on the PSX boards so that this circuit board always has, the frog juicer always has time to catch the short circuit before and change the polarity and fix it before the PSX shuts down or before a command station shuts down. So it's a very easy fix once you know what the problem is. So be aware of that and check the trip speed of your command stations, your boosters, and any short circuit breakers, power managers that you have in line. And you always have to have this device first in line, and then a PSX or other circuit breaker in line, and then the command station or booster. Okay, so, and you always have the speed so that this one's the faster, and then the intermediate one, like the circuit breaker, would be the next faster one, and then finally you have your command station or booster. And in some cases, you might not be using a circuit breaker like the PSX. So this one always needs to be faster than your booster or command station. Other than that, that's the only problem I've ever had in getting these things working. You just hook them up, attach the wires, and turn on the power, and you're ready to go. They're great little devices, and they've won awards for innovation in the past because of this. So I highly recommend them. Give them a look. Just do a search on Google for Frog Juicer or Tam Valley Depot, and you'll be able to find them. They are something special. And with that, these things work great. Now, there are some others out there available on the marketplace, and I'll be showing you those in subsequent videos. But suffice it to say, this is a good introduction to it. I also will say that I will cover the different types of turnouts in a future video so that you'll be able to determine what kind of turnouts you have and what are some of the problems that might be associated with using devices like this with those kind of turnouts. So keep coming back for more here on the DCC Guide, and have a good weekend. Bye now.